Air masses and fronts. Air mass and weather. So, weather patterns result from the movement of larger bodies of air called air masses. Okay? So, air masses are characterized by similar temperatures and almost of moisture at a certain altitude. When air masses move, the characteristics now of the air mass will change. And then the weather in that area over which they move changes. So again, as the air masses move, the characteristics of the air mass change when the weather in the areas over which they move changes as well. So air masses, a large body of air similar in temperature and humidity. So temperature is either going to be warm or cold. Humidity is either going to be moist or dry. So looking at the pictures, what do you think happens to the air mass on dry land? Overland, it's a little drier. What about over water? It's moist. So these are the different types of air masses. We have maritime, which is moist, continental, which is dry, tropical, which is warm, polar, which is cold. Now, location, water. This is going to be land. This is going to be the tropic areas, and this is the pole, right? The poles are usually cold. Tropics are very warm because they're near the equator. The land is going to be more of your drier, and water is going to be moist. So there's four types of air masses. And again, maritime, continental, maritime polar, continental polar. So maritime polar, moist, cold air to west coast of the U.S. Right here, the polar, obviously they're more up north. Dry, cold air. Maritime polar. So this is over here near the water, but it's going to heat a lot of places of Canada. Maritime tropical, moist. This is around your west of, right over here of Mexico. Continental tropical. So this is the drier area, okay? So we're in continental. So, and we know tropical is going to be warmer. And pretty much where we're at. Maritime tropical, which is moist, warm air to the southeast coast of the United States. Now, just something here. Air masses move um, by prevailing winds. The winds cause the air masses to move over land and water. We already talked about wind already, okay? As they move and as they change, it's called air mass modification. The air masses become more like the area and it's moving over, and at the same time, the area mass basically. So here's just some classifications. Just get a quick glance or pause the screen. Here's the other characteristics. Again, get a quick glance and pause the screen. Alright, so this is a review. We already did this. This is gonna be our fourth time. We talked about it with the moon and everything. Now we're talking about it again after we talked about the waves, and now we're talking about the wind, and now here we are. In the northern hemisphere, a path that would be a straight line over a stationary Earth instead is curved to the right. In the southern hemisphere, curvature is to the left. So, as you see here. This effect creates global wind system, and this is again what transport air masses, okay? What is wind again? Wind. Air moves in response to density imbalances created by unequal heating and cooling of the Earth's surfaces. Wind can be thought of as air moving from an area of high pressure to low pressure, okay? High to low. There's 3 types of wind systems, okay? 3 types of wind systems. So we have trade winds, we have prevailing westerlies, we have polar easterlies. Again, some of these words look very familiar. But as well as, these are things that you see on TV. So trade winds move between the equator, 30 degrees north, and south latitude. Here you go. Air sinks, warms, and returns to the equator, westerly direction. Prevailing westerlies, as you see here, boom, 30 and 60 degrees latitude, moves in opposite direction of the trade winds. So if you see the trade winds are going this way, so westerlies decide to go this way. And this again moves across the weather. And polar easterlies, so now if you notice here, occurs at 60 degrees in poles, and it's cold air. A boundary between 2 air masses: cold fronts, warm fronts, stationary front, and occluded fronts. These are our 4 types of fronts. Okay? When air masses meet, cold front. When cold air advances on warm air is violently forced up. Okay? Rising air creates your clouds, rain, and storms. Clouds, rain, storms. So cold fronts is going to give us heavy rain for a short period of time. And you see here, it's a steep slope. So again, showers and thunderstorms. So this is what happens when we have a cold front to come in. We usually have a lot of showers and occasional thunderstorms. Cold front. What does it mean? It get hotter? No. It gets colder. As you see. As it comes in, 38 degrees, and all of a sudden, it was over here 55. What about warm fronts? Well, when warm hits cold air, warm air generally glides over the cold air. Rising in air creates clouds and showers. These are like when it just kind of showers for 2 or 3 seconds and then boom. A lot of times you see this in your Florida region. Alright, so does a warm front get cold or hot? Well, what's the word in front of it? It gets warm. So when a warm or cold front stops moving, okay, usually several days of clouds and showers. The air flows parallel to the front, okay? So several days of clouds and showers if it stops moving. Another type of front, occluded front. Occluded front occurs when the cold front wraps around the warm front. Here's in the picture. All right, so if you ever looked at the news, you will see these symbols. Well, if it's basically the circle pattern, that's a warm front. Triangle pattern, and it's blue, is a cold front. Occluded front is a mixture, okay, but it's all going the same direction. Stationary is opposite directions of the fronts. So, what type of front is that? We have two colors. Okay, here we have the red and we have the blue. So again, those symbols are everything like the news. You see how it, just like the news, things are in color-coded order. So look at here. You got a lot of blue right here. All of a sudden, you get a little bit of red here, and then we have a mixture here. Now look at the temperature map. This can kind of tell you what kind of front's going on, because over here it's all warm. Over here it begins to get colder. So all the way up here is way colder than what it is over here. Now, the Doppler radar. Doppler radar is our radar to show our weather, okay? Now, what is atmospheric pressure? The atmosphere has pressure. The air in 1 inch square column that goes from the Earth's surface all the way up through the atmosphere exerts a pressure of 14.7 pounds per square inch at sea level. So system types: low pressure, cyclones. They form along fronts. Unstable. Rise in air. Winds rotate counter clockwise, okay? Rainy, stormy weather. High pressure, anticyclones. Sinking air, so now it's stable. The sinking air stops clouds from forming. Goes clockwise. Sunny, clear weather. This is showing how we measure atmospheric pressure. This is isobar maps. Points of equal pressure are connected. So if you are equal, again, the points are connected. again, weather station model. Um, this allows us to see the difference: drizzle, rain, smog, hail, thunderstorms, snow, sleet. Again, we already talked about air masses, so if you see those letterings, here's the types of fronts. You have cold, triangles, warm is circles, stationary is squares and triangles in opposite directions, occluded is the same direction. Hurricane, and then we have tornadoes.